Hey there, fellows. Have you ever thought about why those skyscrapers don't just topple over? Like, really? Isn't that amuse you? Or, well, how those bridges spanning enormous kind of like river manage to stay afloat without any hitch? Yeah, and hey, why do some buildings are made with a wood while others go all in with steel and stuff like glass? Pretty simple, right? Well, it's all about the way they're put together, really. Now, let me ask, how do those genius minds designing things figure out which materials to use? Or maybe like how tall a building can stretch? Or where's the perfect spot to plop down a bridge? That's what the magic of engineering is for you, Landies and Ellen. Engineers, the real wizards, real living wizards, design all sorts of stuff, from buildings and dams to airplanes, cars, and even those trusty old, like really big chairs and bicycle frames. They've got one main mission, and what that is? Yes, make things so that they can handle the weight and push back against forces trying to tear them apart. Simple and straight. So, let's chat about forces. For me, a force is like the muscle needed to push or pull an object around. I know that's not kind of definition you read in text, but hey, that's the actual thing. Now, engineers dive into the nitty-gritty. They're all about the loads or external forces acting on a structure. It's like an inside-out tug of war. External forces try to shake things up, but internal stresses, those inner forces, resist and keep everything glued together. So there are 5 pretty cool types of loads engineers play with, and that is tension, compression, shear, bending, and torsion. So in our today's video, we'll break down the forces acting on structures, the pretty basics. Tension, 2 pulling, opposing, forces that stretch an object trying to pull it apart. For example, pulling on a rope, a car towing another car with a chain. The rope and the chain are in tension or are being subjected to a tensile load. Compression, 2 pushing, opposing, forces that squeeze an object, trying to compress it. For example, standing on a soda can, squeezing a piece of wood in a vise. Both the can and the wood are in compression or are being subjected to a compressive load. Shear, 2 pushing or pulling adjacent forces, acting close together, but not directly opposing each other. A shearing blow cuts or rips an object by sliding its molecules apart sideways. For example, pruning shears cutting through a branch, paper cutter cutting paper. The branch and paper are subjected to a shear loading. Another example, pulling on 2 pieces of wood that have been glued together. The glue joint is being subjected to a shear loading. A moment of a force. Understanding a moment of a force is key to understanding the last 2 types of loads. A moment is a turning force caused by a force acting on an object at some distance from a fixed point. Consider the diving board sketch. The heavier the person, force, and the farther they walk out on the board distance, the greater the turning force, which acts on the concrete foundation, fixed point. The stronger the force, and the greater the distance at which it acts, the larger the moment or turning force it will produce. A moment or turning force, M, is calculated by multiplying a force, F, by its moment arm. D, the moment arm is the distance at which the force is applied, taken from the fixed point. Bending, when a moment or turning force is applied to a structural member that is fixed on both ends, such as a pole beam, making it deflect or bend. A moment that causes bending is called a bending moment. Bending produces tension and compression inside a beam or a pole, causing it to smile. The molecules on the top of the smile get squeezed together, while the molecules on the bottom of the smile get stretched out. A beam or pole in bending will fail in tension, break on the side that is being pulled apart. For example, a shelf in a bookcase, and the earlier diving board scenario. Torsion, twisting, created when a moment or turning force is applied to a structural member or piece of material, making it deflect at an angle. Twist, a moment that causes twisting is called a twisting or torsional moment. Torsion produces shear stresses inside the material. A beam in torsion will fail in shear. The twisting action causes the molecules to be slid apart sideways. For example, a pole with a sign hanging off one side. Understanding the moment of a force, which is a turning force caused by a force acting at a distance from a fixed point, is essential for comprehending bending and torsion. The strength of the force and the distance at which it acts determine the magnitude of the moment or turning force. In essence, engineers navigate the intricate world of forces, loads, and moments to craft structures that stand tall, endure, and serve their intended purposes.